This week, your reading assignment is Chapter 2 in your ebook, and Chapter 2 covers choice, opportunity costs, and specialization. So I will be breaking up the lecture into two parts. This particular whiteboard lecture, we will be covering opportunity costs, how we calculate them, and how they relate to specialization. Now, thinking about the decision-making process, the fact that you have to make choices, from an economist perspective, every time you make a choice, there is a cost associated with that choice. We usually refer to it as, costs and benefits of every choice. And the idea is that when you make a choice, the highest valued alternative that must be foregone when that choice is made is referred to the opportunity cost. So generally, we say that every time you make a choice, there's an opportunity cost involved. In other words, what would you have chosen had you not chosen, A over B? That becomes your opportunity cost. So we'll focus on a choice that all of you have made, and that is the choice to go to college. You see right here in the lecture slide. And so I posed the question to students, what are your costs of going to college? There's going to be monetary costs and non-monetary costs, right? In other words, usually when I ask students, what is your cost of going to college, they refer to the monetary cost. So you might say tuition, right? Whatever you had to pay for your tuition, your books, maybe gas, to get to and from school every day. So most students immediately think of all of the actual monetary costs of going to college. But those are not the only costs that you have. You also have the non-monetary costs of going to college. And those are going to vary from person to person. In other words, maybe when I decided to go to college, I was giving up time with my kids. Then that actually becomes a cost of going to college. Now, opportunity cost, you'll notice in the definition, we say is the highest valued alternative. So again, when I made the decision to go to college, there was a lot of things I could be doing with my time instead, right? I could be, again, spending time with my kids. I could be shopping. I could be working. But when we are talking about opportunity costs, we want to remember that we're only referring to the highest valued alternative. In other words, what would I actually be doing if I was not attending school? So not every alternative is an opportunity cost. It's whatever you would actually be doing. So in other words, the opportunity cost to go to college are not only what I would be doing with my time. So for me, it would be time with my kids that I would be spending. But again, I also have to look at all of those monetary costs that I have and think about how would I be spending that money if it wasn't being spent on college, right? So those are how you would calculate your opportunity costs for the decision to go to college. So again, everybody's is going to be different. Maybe for some people, you would be working. So your opportunity costs would include the foregone income that you could have earned had you been at your job right now. Maybe for somebody else, it would be sleeping, So in other words, each one of us is giving up different things when we make the choice to go to college every day. And that's why our opportunity costs are going to be different, because they're based on everybody's individual values. What do you value most? That becomes your opportunity cost. Now, economists believe that people make decisions by comparing the cost and benefits. And an easy way to make sense of this is to think of the opportunity cost as a trade-off. So you'll notice on this next slide here, I say the term opportunity cost is easy to understand when you think of it as a trade-off. In other words, the value of the trade-off is represented by the opportunity cost. So again, every choice you make can be calculated by calculating the value of the trade-off. And again, that is what we refer to as the opportunity cost of your decision. Now, of course, we already learned in Chapter 1 that it's the scarcity and rational self-interest that drive us to make choices where our benefits outweigh our costs, right? Scarcity is what forces us to make choices. There's not unlimited resources. There's not unlimited time. So we have to choose how to spend our time and limited income. And because we believe that we're all inherently rationally self-interested, that it's in our, it's inherent to us that we are automatically going to make decisions where our benefits outweigh our costs, because we're not going to intentionally make choices that make us worse off. So suppose I gave you this example right here, that you can earn $20 an hour tutoring students after class here on campus. Today, however, you cancel your 2-hour tutoring session to attend a movie that costs $10. And I'm asking you, what is the opportunity cost of this decision? So obviously, you make $20 an hour, and that would have been a 2-hour tutoring session. Therefore, the opportunity cost in terms of that monetary value is $40. So part of your opportunity cost is the $40 that you could have earned had you engaged in your tutoring session. However, notice that it says that you decide to attend a movie that costs $10. So in other words, included in your opportunity cost, you have to look at that $10, right? What would you have spent that $10 on had you not gone to the movies? Therefore, you have to look at what is the highest valued alternative for that $10. That is also part of your opportunity cost. So not only is the opportunity cost, the foregone income, $40, but it's also what did you give up when you spent that $10 to go to the movies. So again, let's say that you would have spent that $10 on, $10 of groceries. That would mean that the opportunity cost of going to that movie was the $40 plus the $10 in groceries that you gave up. So again, you have to look at the total cost, everything you gave up when you made that choice. One other thing that you have to think about is, the time that you spend. How would you have spent that time? So in this problem, obviously, we already know, because it says you canceled your 2-hour tutoring session to go to the movie. So had you not been at the movies, you would have spent 2 hours tutoring. But sometimes problems aren't necessarily that explicit. So you have to, kind of figure out for yourself what, would you or the individual be doing with their time had they not decided to do one activity over another. Now, in economics, we do like to use graphs to illustrate a lot of these concepts that we're going to be learning. So I want to introduce you to one of the first graphs you need to learn, and that is what we call a production possibility curve. A production possibility curve is what we use to illustrate graphically the benefits and costs that that are associated with a decision that you make. So we can use a production possibility curve to illustrate choices for an individual, or we can use a production possibility curve to illustrate the choices that are faced by a business or by society as a whole. So the first example we're going to be looking at is a production possibility curve for society as a whole, because we know that society as a whole has opportunity costs, right? We, the United States, don't have an unlimited amount of resources. Therefore, we have opportunity costs. Every time we make decisions, there's trade-offs involved. We have to decide what do we value more, and then we have to forego everything else. So again, let's take a look at what a production possibility curve looks like. So here we have a production possibility curve set up for a hypothetical economy. And so you'll notice that it is a line graph with an X and Y axis, which means we're basically comparing two different variables, two different types of goods or services that we as a society can produce. So notice over here on this axis, it says defense goods. So that would be any goods that we're producing that are related to national defense, let's say. But of course, goods and services related to national defense are not the only goods and services that we produce. We produce a multitude of other goods and services. However, we only have one other axis. So notice down here, we just say non-defense goods and services. So we lump everything else that we could possibly produce into just one big category. And that is exactly what we have to do for a production possibility curve because of the fact that we can only compare two variables. We can't have a production possibility curve that has, multiple axes for every single type of good that we produce. So in other words, we just have to divide it up into two categories. So in this example, we can either allocate our goods and services or resources to the production of defense goods and services, or we can allocate our resources to the production of non-defense goods and services. And so what the production possibility curve is illustrating is the maximum amount of goods and services that our society can create or produce based on the current level of our resources. Again, let's say this was for the United States. We only have so much land, labor, and capital. And so what we would be saying is based on the current level of land, labor, and capital that we have, this curve represents the maximum amount of output that we can produce. And also what you see here is I have a schedule of information or a table of information that I use in order to plot my production possibility curve. So notice that point A says if that is where we produce, we will be able to produce 200 units of defense goods. However, that leaves nothing left over to produce any non-defense goods. So that would be right here. Again, we have the other side down here at point E. At point E, if we used all of our resources for non-defense goods, we can produce 160 units of non-defense goods, but then of course that leaves nothing left over to produce defense goods. And then every point in between represents where we're allocating resources to the production of both, right? So if we were right here in the middle of our curve at point C, we're allocating resources both to the production of defense goods and non-defense goods. So again, we can look at our schedule and see at point C, we're able to produce 130 units of defense goods while producing 125 units of non-defense goods. So I just want to make sure that you can look at a production possibility curve and interpret the data, right? In other words, if you were given a schedule of information, you know that you simply take the data in that table to plot your production possibility curve. And so again, every point is representing a point of production where you're using a combination of resources to produce, different combinations of goods and services. Now notice that we also have a point within our production possibility curve right here, F1. F1 represents a point of underutilized resources, right? At F1, we're producing 130 units of defense goods and 25 units of non-defense goods. However, notice that we can still move up to our production possibility curve or move down and acquire more of either defense goods or non-defense goods, which basically means that we are underutilizing our resources. We have resources, land, labor, and capital, that are capable of being used for production. However, they're not being used, which is why we are producing within our production possibility curve. So the entire blue shaded area represents points of production where we are not utilizing all of our resources. This is going to occur when our society is in a recession. In other words, think of periods of recessions that we've gone through. We have land, labor, and capital that is perfectly capable of being utilized by firms to produce goods and services, and yet they're not. So just to give you an idea of points in time where society is underutilizing their resources, they're producing less than they're capable of producing simply because of the economy. Now also notice that we have another point out here, point G. G represents an impossible combination. In other words, maybe we want to produce combination G. However, we've already said our production possibility curve represents the maximum amount of output that we're able to produce. Therefore, based on our current level of resources, it's impossible for us to produce at point G. That does not mean that we cannot produce at point G in the future. In other words, society is not forever fixed in terms of the amount of resources that it has, nor are resources fixed in terms of their production capabilities, which means in the future, our production possibility curve can actually shift, just like we see here in this graph. In other words, over time, your resources can A, either become more productive, or B, you can actually acquire more resources, and that will cause your production possibility curve to shift. So I like to use the example, think about a computer. Think about a computer's production capability, when computers were first invented back, 1980, opposed to a computer that is produced today. Do you think the production capabilities are vastly different? And of course, I'm assuming that you're going to say yes, and that would be absolutely correct. In other words, a computer today is much more productive in terms of output than a computer, 40 years ago. So just to give you an idea of how you don't necessarily have to have more resources, so we don't have to have more computers today, but we can just have computers that are actually just more productive today. Human workers can be the same way, right? In other words, maybe just the workers that a firm employs become more productive over time. So again, resources themselves can become more productive, which allow firms to then produce more goods and services, which then shift our production possibility curve out. But your production possibility curve, again, can also shift simply because you do acquire more resources, allowing you then to become more productive. Now, going back to our original production possibility curve that we were looking at, what the production possibility curve allows us to do is calculate the opportunity costs that are involved when society decides it wants to produce more or less of any given good or service. So we already said that our society has a limited amount of land, labor, and capital, which is represented by that production possibility curve. And based on how we allocate our limited resources, we can produce any combination that is along that production possibility curve. And so let's say that we are currently producing at point B. So we can look at this at the production possibility curve itself, or we can look at our schedule and we can see that at point B, we're producing 175 units of defense goods and 75 units of non-defense goods. And let's say that we decide that we want to move from point B to point C. So we're going to move down along our production possibility curve like so, going from point B to point C. All right, so from here to here, we see, and we want to know what are the opportunity costs associated with that decision. And so again, all we have to do is compare what did we gain versus what did we give up. And that allows us actually to not only calculate our opportunity cost, but also any benefits that we received from that choice. So again, we went from producing 175 defense, I'll just use the letter D, to producing 130 defense units, right? So we lost 45 units of defense goods. So that's what we gave up, which means that is our opportunity cost. In other words, whatever you give up is what is your opportunity cost with that decision. So moving from point B to C, we went from producing 175 units to only 130 units. Therefore, the cost associated with that choice to, reallocate resources from the production of defense to non-defense was 45 units of defense good. But we can also calculate what were our marginal benefits from that choice, right? The benefits are what you gain when you make a choice. So again, what we can see is that prior, when we were at point B along our production possibility curve, we were producing 75 units of non-defense goods. And when we moved to point C, we're now producing 125 units of non-defense goods. Therefore, we gained 50 units of non-defense goods. Again, I apologize for my messy handwriting. So again, it's very, very easy to mathematically calculate what the marginal costs and benefits of this decision was. The costs are what we give up, so we gave up 45 units of defense goods, and the benefits are what we gain, and we gain 50 units of non-defense goods. Now, I do want to emphasize that we are not talking about dollar amounts here. These are just units of goods. Okay, so we don't know what the dollar value of these goods are. We're just saying this is what we gain and this is what we give up. But these are not dollar values. These are just units of goods that are produced. Now let's say that we want to further reallocate goods from the production of defense to non-defense, right? In other words, maybe not only did we move from point B to C, but we also want to move from point C to D. So again, you can think of this like as if maybe we had been in a time of war at one point, but now we're starting to pull troops out and want to reallocate tax dollars to the production of other goods and services, opposed to just allocating everything towards national defense. So again, we moved from B to C on the previous slide. Now we want to move from C to D. We want to continue to reallocate resources to the production of non-defense goods. So we would do the same thing, right? To look at the opportunity costs, you look to see what you give up. So at point C, we're producing 130 units of defense goods. If we move to point D, we're now only producing 70 units of defense goods. Therefore, we're giving up 60 units of defense goods. So that again is our opportunity cost. That is what we are giving up. And then of course we can calculate what our marginal benefits are. That is what we gain. So again, moving from C to D, initially we had 125 units of non-defense goods, and now we'll be producing 150 units of non-defense goods. Therefore, we had a net gain of 25 units of non-defense goods. So this is our marginal benefit, 25 units. This is our marginal opportunity cost, 60 units. Now notice what happened. In other words, on the previous example, if we go back here, moving from B to C, we gained 45 units of defense goods we gave up 45 units of defense goods and gained 50 units of non-defense goods. But to move from C to D, notice what happens. We had to give up more. Now we have to give up 60 units of defense goods, yet we get back less. Now we're only gaining 25 units of non-defense goods. Now, looking at it graphically, we understand why that happens. In other words, it's that bowed out shape of that production possibility curve that causes it mathematically to work out that way. In other words, as we move down along that production possibility curve, we will have to give up more and more and more, and yet get back less and less and less. And we want to understand why that is. In economics, we use the term specialization to explain why that's going to take place. Generally, resources are not going to be perfectly adaptable to alternative uses. Thus, as we transfer resources to be used in the production of other goods and services, we experience what's called the law of increasing opportunity costs. Again, by definition, you'll see that right here, the observation that the opportunity cost of additional units of a good generally increase as society attempts to produce more of that good. So in other words, some resources are more adaptable than others. So it would make sense that when we first start to reallocate resources, we want to reallocate our least specialized. In other words, the resources that are going to be more adaptable. So least specialized resources will be transferred first. So again, let's say we're talking about like the resource of labor, right? So just specifically, we can reallocate workers from the production of defense to non-defense goods. Well, you may have people that are employed in fields like secretarial work, people that are employed in janitorial work, Just to give you some examples of people that can be employed in one field, and yet their skills may be more adaptable to moving into another field. So again, think about somebody that does secretarial work. Could you do the same work, whether you're working for the Department of Defense or if you're working for a school? Or let's say that you are engaged in janitorial work. Could you clean a building just as effectively for the Department of Defense as you could for a hospital? And your answer should be yes. In other words, these are labor resources that are not that specialized, or again, we would say are the least specialized. They are more adaptable to alternative uses. So we can take these resources of labor and take these people and take them from working for production of national defense and then reallocate them in areas of non-defense, and we're not going to lose a lot, right? So in other words, that's why at the top part of the production possibility curve, you don't necessarily lose a lot of output as you're transferring your least specialized resources first. However, after you've transferred all of your resources that aren't as specialized, all that's left are your specialized resources, right? In other words, eventually you reach a point where the only resources that are left are highly specialized in the field in which they are currently used. So if we're talking about national defense specifically, maybe we're talking about a rocket scientist. Maybe we're talking about a rocket engineer. You can tell that I'm not very familiar with the type of occupations that are highly specialized in national defense. Maybe we're talking about someone that's employed as a fighter pilot for national defense. In other words, I'm trying to emphasize here that you have some fields of work in terms of the resource of labor specifically that are going to be highly specialized. In other words, their occupational skills are not going to be perfectly adaptable to an alternative use, the same way a secretary or a janitor would be, which explains why we would get so much out of them if they're employed in the field of national defense, yet when we try to transfer that resource of labor to an alternative use, so in other words, move down along our production possibility curve, we're not going to get as much output from them when we try to employ them in another field, because they were very, very specialized for one particular field of work, and trying to transfer them to another field of work, we're just not going to get as much output. So in other words, a rocket scientist or somebody that works in engineering for national defense, we're going to get a ton of output from them employed in the field of national defense. But if we transfer them to maybe just, being employed as a teacher or something, we're not going to get as much output out of them as in terms of the value of output we would have gotten had they stayed employed in the area of national defense. And then of course you want to apply this line of thinking to all resources, not just labor, but all resources have, the capability of being highly specialized. So again, if we're talking about a resource of a table versus a fighter jet, right? In other words, these are two resources that are probably both utilized in terms of national defense, right? You probably have tables that are used within the buildings, and then you also have fighter jets. You can probably easily determine which resource is going to be more specialized than the other. In other words, which one is more adaptable to alternative uses. Obviously, it's going to be the table, right? I can take a table out of the building of national defense and put it in a building, in a hospital, in a school, what have you, and I will be able to utilize that table and get, use out of it. Whereas a fighter jet is highly specialized for national defense, but if we are no longer utilizing it for national defense, what else could we possibly use it for? Maybe put it in a museum or something. I don't know. But in other words, again, just to get an idea of how specialized resources, those are your resources that are not perfectly adaptable to alternative uses, and they cause that bowed out shape of the production possibility curve. Now, if we look at our production possibility curve that we had and just add more points to it, it makes it easier to understand, again, the law of increasing costs that are associated with specialization. In other words, notice down here on our axis for non-defense goods, every time we move to a different point along our production possibility curve, we are gaining 25 units of non-defense goods. So going from point A to point B, from point A to B, we went from 0 non-defense to 25. From B to C, we went from 25 to 50. From C to D, we go from 50 to 75, so on and so forth. So again, when we're looking down here, we can see that we're getting 25 units moving from point to point. However, notice what we're giving up is not the same every time we move from, point to point to point. So moving from point A to B, looking at our schedule here, we only had to give up 5 units of defense goods. Moving from point B to C, we only had to give up 7 units. Moving from C to D, 13. But again, you see what's going on here. Every time we want 25 more units of non-defense goods, we have to give up more and more of the defense goods. So that's the law of increasing marginal opportunity cost that is associated with specialization. So again, if we continue, notice that once we get all the way down here, going, from G to H, at that point we actually have to give up 75 units of defense goods in order to only get 25 more units of non-defense goods. So again, just looking at the marginal opportunity cost as we move down this production possibility curve, it's very easy to see that law of increasing opportunity cost, the idea that every time I want 25 more units of the non-defense production, I'm going to have to give up more and more and more of the defense goods. And if we were looking at it going the other direction, you would see the same trend. So it doesn't matter if you're going up the production possibility curve or down the production possibility curve, the law of increasing relative cost is going to apply. So if it was the opposite and I was producing at point H for non-defense goods and I wanted to get more and more defense goods as I move up along the production possibility curve, I would have to give up more and more and more non-defense goods in order to get more defense goods. All right, so now that we know that the reason why we had that law of increasing relative costs is because of specialization, we want to know, well, why does specialization occur? Why do we have specialized resources? And so I generally pose the question to students, why are you here in college? What kind of degree are you getting? Are you going to graduate with a degree in everything and anything? Or are you getting a degree in a specific field? And of course, you're going to answer, well, yeah, I'm getting a degree, in business, or I'm getting a degree in biology. In other words, you are making yourself a specialized resource. You're not going to go into the labor market and be able to get any job that's out there. You're going to be able to get a job where your labor is highly specialized for whatever field you go into. So again, I can look at myself as an example for that. I majored in economics, therefore I'm highly specialized in economics. I couldn't come to Bakersfield College and then expect to teach, a biology course, because my resource of labor is specific to be specialized in economics. So each one of you is going to become a specialized resource in the labor market, depending on what you're majoring in. And so the question is, well, why do you do that? Why are you here in college, specializing in a particular field? Because, again, it's going to allow you to become not only more valuable, right? In other words, you're doing it because you want to have a higher wage in the labor market, but it also makes you more productive. You're going to be able to be a more productive worker in the labor market when you are specialized. So again, think about that in terms of all resources. If we have all of these specialized resources of land, labor, and capital, that means we have all these resources that are more productive. Then what that means is that we can produce more goods and services overall in the world with specialization. And there's no argument with that. Every economist is going to agree that, because of specialization, because we create specialized resources that are then utilized to produce goods and services, we have more goods and services overall in the world than what we would have if we did not specialize, right? Now, just because we have more goods and services overall does not mean that those additional goods and services are equally distributed, right? We don't all gain equally from the increase in output. However, we just know that there is no argument that the world overall has more goods and services than it would have if there was no specialization. So now that we're specialized, that means we're not producing everything, right? So in other words, if I just specialize in teaching economics, how do I get all the other goods and services that I want? Because now I don't grow my own food, I don't build my own housing, I don't, create my own modes of transportation. In other words, how do I get everything else that I want that I no longer produce because I'm only specializing in the production of what I'm best at? Well, in economics, we say that overall, when people and countries specialize in the production of, particular goods, but they want other goods that they don't produce, the way we get them is through trade, right? So we know that countries as a whole trade with one another to get the goods and services that they want that they don't produce. So in the next lecture for this week for chapter 2, I will go into the specifics of trade and more specifically how we calculate the gains from trade when countries and individuals engage.